Hi everyone. My name is Max, and I would like to present the new zero-cost structured logging called LogStage. Okay, so excuse me. So about its power and how it could be the best debugging instrument and for your development and maintenance at all. So yet another logger, yeah. The problem with current logging solution is that they provide the plain text data. This makes it hard to query them and any sort of useful information. What is a structured logging at all? Structured logging is a way of providing machine-friendly formatted event messages of your system. It is well parsed, well queried, and provides tons of potential and vital information about your code. What could be the common use cases of dealing with logs? You can trace your app state or even targeted user request flow. You can go deep through logs to see what the source was laid down, which thread pool has been exhausted, which batch iteration was last during the last pooling. Metrics could help you calculate the median time of DB calls or WebSocket connection latency even. You may provide event analytics for any entity or event group, which could be potentially vital during A/B testing, for example. Let's take a look what could be a real challenge during using libs logging, especially for young developers. The first one is broken solid and lots of magic. Let's see some code examples of your most common frameworks. The first one is Fluent2D. It's a third-party login library. As you can see, you need to use the Fluent login factory and initiate get logger with some parameters. Maybe it could be some text data with config, I don't know. But it's really complicated. And the next one is data hash map. You need to set up MDC by yourself during runtime. It's hard. I think. The Scala logging. Why we need to extend with lazy logging? I'm sorry. Why do we need to extend lazy logging if we want to define just a class and that's all? Why do we need to extend its logic? I think it's redundant, and we need to set it up manually. And I don't know. It's a good idea. And Finatra. You need also to extend the logging, so solid is completely broken and it's hard. Production and readiness. When we need to include the appropriate logging library, we need to have a full instrument. We need to have asynchronous syncs, the file rotation, JSON rendering, MDC or dynamic context, and no performance hotspots. And there are no any library which provide full benefits and full these ones. The singletons and jar health. If you build a system with isolated class loaders, there are in logback and SL4G the singletons, and it's complicated to exclude them by yourself. And this one, this one, this one, this one, another one, and another one. Gosh, more than 3K results when you need to exclude by yourself. We always write code that is always structured. So logging always should be easy to read. As you can see, we have some service, we have some values, and we pass them and render in some way. And as you can see in below, how it can be rendered and easier to deal with when you use some things for your logs. For example, the Kafka Panda, or you need to cross them through Kibana. You can pass the JSON rendered strings and traverse them with any pain. So please welcome the LogStage, the first class login framework of Scala. And let's get into their features. Macro-based structuring and context extraction. We provide you all information about argument names, type, their ordering. We also provide the static info about file, line, class, and function has been invoked. We also provide the static part of our message, the message template, or well-known interpolation context. We will describe later why do we need them, actually. Aliasing for references. When you pass into interpolation context some data, the pure references, for example, the random next int, you may alias them with a random number, and you will see how your log message would be rendered in some readable way. Dynamic context and method granularity. We also provide an instrument that could help you to define isolated logging context for each function of your service. For example, if you have some method to revoke a user token, you need to know what the user was, its ID, its company, and maybe you have some static info about API, what was method, the name, revoke token. So we pass info, user has an expired token, start revoking. And we trying to revoke them, and either we have successfully revoked trace, or we can fail and make some info why we got failed. And as you can see below, you will find how the log messages has been structured. So it's quite easy and quite vital to have some context when you need to traverse through these logs. Reference configuration. It also supports to set up your log router and some things by just building your reference config. But for right now, it needs to be rethink and be more optimized. But it still is. SLF4G backend. You should forget about logback. You just need to include this library and enjoy this rendered and well-performed messages. Out-of-box provisioning. We provide a console sync. We provide file sync. We provide asynchronous mechanism. For right now, it's a single worker thread at the moment, but if you use wrappers for your ZIO or Monix task, it could help also asynchronous flush your data. And string and JSON rendering. We have effectful adapters for ZIO, CATS, and Monix. We also provide the info about fiber ID, and it could be also potential interested info. Automatic structure identifiers. What does it mean? So imagine that you have some log, and it has a follow format. And as you can see, I hope you see, the template is, and it was how you interpolate your string. We pass various names, and you may just query through the database if you use a structured DB for storing your logs, and tell, please give me some logs with such template, and you will see appropriate messages. It's quite easy to look through how your system works. Let's dive into coding. I would like to share with some code, but unfortunately I have some error and I need to figure out what there was. And we need to write down some code, some service. For example, routine work, working with. Let's work with some advertising. Let's pull some data. We need to provide batch working that will scheduling pull the data from your advertising platforms, and you need to handle how it has been processed, each batch iteration, when it was pulled and when it was flushed into some storage you have. So we have a simple add report service. We have add report service, which have some method called pull reports for user ID and specific ad platform. We have 3 platforms called bad guys, good fellows, and another good ones. I made a typo, I'm sorry. And let's imagine that bad guys always provide some broken responses, maybe rate limiters and or another ones. So we will note the read from network that if we use bad guys, we always get error log that rate limit has been exceeded. And for others, we received some list of data. And we also need to put into S3. So quite familiar case of usage. So as you can see, we pull reports and we define the granular log. It has a user ID and ad platform. And we define that we started our work, we read from network, put into S3, we're trying to make it asynchronous. Imagine that we pull, that we flash data until we can read, some still walker. And informate about the batching has been completed. And we also need to store our logs data into, imagine the Postgres. It was quite an easier example to define. And we also trying to flash the data. We have some source policy. We use this source that helps us to automatic pass entries log into JSON. And we're trying to flash. We flash in batching with limit, for example, of 10, and inserting into database. I don't know actually what has been happened, but I've got some weird error in my VS code that it can't find main class. And I'm really sorry about that, and I will try to figure out what there was. But let's see. Let's imagine that we have processed it. So we would like, when we got some logs, imagine the operation, and you need to know how many requests got issued with rate limit, because somebody told that we don't have any data for bad guys. They are empty. So we just query. And as you can see, that we got 211 messages with rate limit exceeded. Oh, let's take a look what we have at all. How many data we have, actually. And as you can see, it's format. If you will use appropriate structured DB, I don't know exactly what it could be, you will put the JSON correctly. But imagine that we use a Postgres, and it's all. If we have a full log message in JSON and a timestamp when it has been, when the event has been. Let's calculate how many data we have processed for Goodfellows. And as you can see, that we calculate how many rows we actually processed from advertising platform and put into a string lists, for example. And we can see, and it could be used as some metrics. Let's imagine that we will want to know all users where rate limit exceeded. We need to know which users has invoked and where they got an issue. And we will see that we get user IDs, and then we could use some another query. So please, why user ID with 10 got some issue? Maybe some another logic was broken. Let's dive into its log. So we can use, please let me some data for user ID, which in 1 or 10, it doesn't actually matter. So it will show you the message when which has completed. So, oh, for user 10, there are no. Let's look. What about 1? Oh, sorry. Yeah, we can see that when the user ID 1 processed successfully, for each advertising platform, we did not include a specific one. And as I show, how many requests got issued with rate limit. So as you can see, this one could be used as a powerful tool for monitoring and querying your state of application. And I think that it's completely vital and important if you want to build reliable systems and define where the issue was as faster as possible. You can, for example, find the flow for a specific user when the issue has been reproduced, and you can and your DevOps, for example, can dump your appropriate logs, and you can find in your dynamic context where the variables have specific values, and you can reproduce isolated tests. And it could be really important to find out as fast as possible when the bug was. Maybe your devs did not include some edge cases. So another feature is almost no dependencies exclude the SLF4G interoperation, which may impact, as I said before, on working system with isolated class loaders. You need to exclude by yourself singletons. It also modular. You can define by yourself some policies for your file rendering, for your console rendering, for your file sync, for your console sync. It could be pretty, I mean colorful, with IDE hyperlinks, and so on. You can define all of your file rotation, how many files you need to, the latest you need to store. I'm sorry. And you need to also define your log router with log level for each packages. And define your logger with sinks and your router. It also DI ready. It means that if you heard presentation before, you can define your DI context for your logger. You can bind it and use lambdas. You can pass into your logger sinks that has been defined in other modulars. For example, you have production sinks, maybe Kafka Panda, or console with no steroid, I mean with no hyperlinks, with no color, and so on. Just a plain text and it's all. And for test, you need to have console IDE support and colored sync. And you don't need to, while testing, run all your sinks. You don't need to append into Kafka. You don't need to append it a file. You just need to look how it looks in console. In 2 separate settings set, I think it's really cool. We also support this stage out of box, that you don't need to set it up by yourself. We also have, I'm sorry about typo. We also have some table for comparing current logging libraries. And as you can see, we put the LogStage, the logback plus SL4G, and Scala logging. But also I found interesting in Scribe and A-Frame. Scribe is quite famous about its performance, and A-Frame is quite an analog, but it have many drawbacks which we don't have. So as you can see, we have some features. It must be structured, solid rules, no singletons, modularity, asynchronous, DI readiness, colorful, dynamic context or MDC, and file rotation. And as you can see, most of them are not support, actually all features. But I think that this set of necessary features could be if you want to use in production your log. library. And we also have planned to work with. We need to, as I said before, we're thinking of rendering policy. We need to rethink about reference configuration. We need to integrate with some Elasticsearch, Kafka, Logback, and Azure. And we need to profile and have some optimization performance, because we are not so fast as Scribe, for example. And welcome to contribution. We are free, and welcome to new guys who have fresh ideas, and you can try by yourself and tell us what you think about it and how it could be. We also have a GitHub channel and have some fans, and you can describe what you want. Okay, thanks for listening, and if you have some questions, please feel free to ask, and I will figure out, if I have a couple of minutes, what the reason was, because I really would love to show you how it should be worked in real. Sorry about that. I've never thought that it could be.
Hi.
Yeah.
Thank you for your presentation. Have you thought about performance bottlenecks or maybe boost of using your library?
About benchmarking and performance, we use it in production more than 17 months, and it works pretty well with no hotspots, but we don't have actually time for completely benchmark it. And I've created some repository which called Scala login benchmarks. You can see what the test scenario is, and you can find and stay tuned about our process of optimization and performance. But it works well in production, as we don't have any spots and issues with.
Yep. Hi. Thank you for the presentation. My question was about dynamic context. On the diagram you showed, or table, there was no dynamic context in log4j, which is weird because we are using it's MDC, where I can put the dynamic context of the log, and everything that I log will be supported with this. And the question is actually about how do you implement the dynamic context, because in the log4j, the guys use thread local for storing the data for dynamic context. And what do you use internally to store the dynamic context in your library? Thank you.
Actually, we use the macro-based solution, and we put all data using macros without thread locals. And our benefit of MDC is that we don't need to pass your key values by yourself. You just build your string cross-string interpolating, and we, thanks for macros, also could build you the key value with no any manual settings.
Thank you for a great presentation. And I have actually two questions. Like, one is very simple. Like, do you have also, for example, in development, I would like to see the debug logs, but not in production. And do you have also like the macro when I call like logger.debug that the JSON part is not calculated at all? Because in some libraries you need to, if you do not want to calculate the part which is logged, you need to do like if logger debug is enabled and then log it. So this is the first question, and the second, if I use your solution, does it make sense to use Splunk or Kibana and Elasticsearch, or you do not use these at all?
Thanks for the questions. The first one is there's also resolve is login level in compile time. And the second question, yes, you can actually use with Elasticsearch and Kibana, but as I said, we need to add some interrupts, because we actually don't use Elasticsearch. We just flush our data into DB, and operations guys read cruise the querying. And in the future, we also obviously add them because it's potentially vital for our users, because most of you use Elasticsearch and Kibana for this one. I really want to fix my mistake, and if you give me 1 minute, I can show you how it works well in live, because in the words it looks anotherly. But you are free to ask another questions if you have. I really appreciate for them. About the benchmarking, I can simultaneously tell that we have some drawbacks, even comparing with logback, because we did not actually use files physical, and we just stream our data to DB, and we got unexpectedly issue during development, but it will be fixed as fast as it could, because we also have another products called IDL and LogStage, as you maybe heard before, and the logging works for our purpose pretty well, but we also need to prepare it more properly for usage of others. But they really make an impact on performance, and we do not actually ignore any hotspots and possible bugs and overheads. 1 minute, please. Gosh. We could also have some patience and ideas about integrating with Common. It is named, yeah, for really use our logs as a really metrics tool, and you can stay tuned. And also we have some issue from one guy in GitHub channel that said that why we just can't send about the log case classes directly, and it could be rendered as a key value, as a JSON. And we also would like to challenge with it. Maybe it could be also interesting one with no passing by yourself. Okay, I'm already set up. Oh gosh, I'm actually got it. What the reason was? No, I deleted actually my main class. Oh gosh, 1 sec.
May I ask one question?
Yeah, sure.
Have you thought about implementing such thing, but not for logging, for metrics? For instance, you could measure thread usage, garbage collector activity, and send it to Prometheus with all the context LogStage provides, for instance. Do you have such?
Yeah.
Oh, it's great.
Yes, we have. We actually, our main goal was to deliver all vital features, and the performance was unfortunately the second part of our work, because it was kind of research and challenge. Do we actually could deliver what we have and in our login desire library? And we actually have, and we were really appreciate about that. Okay, I will try to make this one again. Sorry guys to bother you. I shouldn't use the VS Code. Yeah. Okay. Now we now we have. Oh, yeah, cool. Okay, so let's get into our code of main file that has been reincarnated. So as you can see, we define some execution contexts, some thread pools for our. We use the Zio, and we have some BO runner for its unsafe running in main. We have some text scene and JSON sync we defined before. It's flush into Postgres pure JSONs. And we define our logger, we define our service, we define what platforms we actually interested in. It's a bad guys and good fellows. And we have how many users we want to send. Okay, let it be about 15. And for each parallel 5, we flush the data for each user and pull reports. Okay, and run it. And as you can see, how it has been started. For example, the user 1 has ID 1. For add bad guys, it started processing batching and got unexpectedly skipping or uploading to S3 because rate limit exceeded. But if you look through Goodfellows for user ID 7, it started processing batching. And if you will find him, he received 2,000 rows from advertising platform and uploading to S3 successfully. Well, okay. So as you can see, it works well, and thanks for dynamic context, you can traverse through your logs more faster and more understandable. And also, if you have some errors, you can you can navigate as fast as possible to your hyperlinks in IDE. So that's all. It also tells about log level, obviously, timestamp, and which was service and function has been invoked, and which thread was. And if I define in my logger that I want to also use fiber ID for task and Monix and ZIO fibers, it will show me also the fiber ID. And so that is all. That is all actually, and thanks for watching and for your questions.